All right, hi everybody, and welcome. So welcome to the Calling All Systems. This is the first Calling All Systems program. My name is Barclay Brown. I'm the Associate Director for AI Research in Collins Aerospace. I'm also the INCOSE CIO, and I'm also your host for today's program. So let me start out by acknowledging Honor Lind, who is here. She's the INCOSE Director of Marketing and Communications. This whole program is kind of her brainchild, right? And she organized this and has set this whole thing up. So pretty amazing. Thank you for doing that. It's quite a successful program already. Next, I want to recognize the sponsor for the series, Calling All Systems for All, is Siemens, and then our is Dassault. I'm saying this wrong. The sponsor for the series, the whole series of sessions, is Dassault, and our special sponsor for this particular session is Siemens. So we're acknowledging that. So let me start out by introducing our panelists for the program here, and then we'll jump right into content. So let me go through each panelist, and you can sort of wave as I introduce you if you like. So first is Todd Tuthill, his Vice President for Aerospace and Defense Strategy and Marketing at Siemens Digital Industry Software. Todd joined Siemens in June of 2022 after more than 30 years in aerospace and defense industry, including roles at McDonnell Douglas, Boeing, Moog, Raytheon. That's where I knew Todd, right, because when we both worked at Raytheon, and Siemens. In his new role at Siemens, he's a passionate advocate for the advancement of digital transformation across the A&D industry. Next up, Brett Hillhouse is a global leader for IBM sustainability software. His responsibility at IBM includes industry and technology strategy, as well as customer success for automotive companies around the world. His 25 plus years of industry experience include transformation engagements at global automotive and aerospace OEMs and tier 1 suppliers. Previously, Brett held several industry leadership positions at IBM and Siemens, formerly SDRC. He holds a BS in mechanical and aerospace engineering from Cornell. Next up, Stephanie Sharo Chiesi. Chiesi, I did it wrong. I've been teaching everybody how to say your name, Stephanie, and I messed it up. Chiesi, it's like Chianti, right? That's what you taught me. You taught it to me. She's a doctoral candidate at Stevens Institute of Technology in the School of Systems and Enterprises, and she's currently a principal aerospace systems engineer at Blue Origin and digital thread lead for Orbital Reef. Prior to joining Blue Origin, she was chief digital engineer at SAIC, a senior principal systems engineer at Raytheon Missiles and Defense, where we work together, in fact. She's a CSEP, that's a certified systems engineering professional, and inventor with 5 awarded patents. She holds 2 bachelor's degrees in aeronautics, astronautics, and in biology, and a master's degree in aeronautics and astronautics, all from MIT. Troy Peterson, next up, SSI Fellow and SSI Vice President and Fellow. Troy's a recognized leader in developing model-based solutions for complex systems and methodologies while at SSI, at Booz Allen, at Ford Motor Company. Troy is currently co-chair of the MBSE Initiative and MBSE Patterns Working Group at INCOSE. So he's one of our MBSE leaders in INCOSE. Troy received a BS in Mechanical Engineering from Michigan State, an MS in Technology from Rensselaer Polytechnic Institute, and an advanced graduate certificate in Systems Design and Management from MIT. He also holds INCOSE CSEP and PMI PMP and ASQ Six Sigma Black Belt certifications. All right. And last but certainly not least, Garrett Thurston is a global program digital transformation senior director. In his global transformation role, he works with key strategic accounts. Dr. Thurston marshals Dassault System institutional resources to manage their time and value, the value extent achieved. Prior to joining Dassault, Garrett built and managed an ADS, Aerospace, Defense, and Security business. Garrett has a doctorate in engineering, and his dissertation was a DARPA-funded program which focused on modeling and simulation. All right, so that's our panel. So everybody, round of applause. Thank you very much. Welcome to all our panelists. So I want to jump right in here, and my role here is to pose some questions that may get some things going. You're welcome, by the way, this is to all our attendees, to ask questions in the chat, if you like, or in the Q&A. Asking them in the Q&A will probably get more panelist attention, and asking them in the chat may get panelists or others to interact, because the attendees may also chime in. So it's up to you how you want to interact with us as we get going here. We have a large number of attendees, as you may know, several hundred, so we won't promise to answer every question or to respond to every prompt. I guess I'll just put it that way. So let me start out with, perhaps this is a softball and perhaps not to my fellow panelists here. The question is, what is MBSE? And what is MBSE? Not just, you could think of the answer as, okay, what is it now? And then what is it in 5 or 10 years? Does the definition of what MBSE is it going to change? So let me paint the picture just a little bit. There's a range of possibilities. Some say MBSE is only about the work of systems engineering. Some say it's only about models or only about descriptive models, or some might even imply it's only about SysML and what we do in SysML. Or is it about all engineering of systems, and it's all aspects of engineering. So let me throw that out to whoever would like to go on the panel. What is MBSE?
I'll start.
Sure.
MBSE today, Barclay, and by the way, thank you for inviting us, putting this together. Thank you to you and Honor. This is a great panel. Looking forward to this. I'd say MBSE today it's the beginning of what I'll say, the digital transformation of systems engineering. And when I think about where I'd like it to go, I feel like we've just dipped our toe in the water. I think there's benefits and things that we've seen from it, but I think there's a long way for us to go and lots of opportunities for us to grow.
Okay, terrific.
I'll actually jump off on that one too. I think we certainly talk about MBSE and think about a lot of our different pillars, our language, our tools, our methodology. And that's very different than the way modeling transformed a number of the other disciplines. I think a lot of what we see the future of MBSE and are moving towards that has already been to expand into how we interact with other domains, other disciplines, more so than any of those areas interacted with us in their modeling transformation. So I think that's something that is unique about MBSE in terms of the reach out it has across domains as we expand and grow into the future there.
And I think it's also applying to any kind of system. I mean, I'm on a DAC panel, the IEEE conference, and it's about chip design and how do they use systems engineering for chip design and to address certain performance problems, Moore's law, et cetera. And it's interesting because I'm often getting involved in domain-specific application of leveraging MBSE down to that next level. And I think we can do a better job in INCOSE of supporting that more explicitly than we do.
It's a really interesting point. I'll chime in there. Sometimes when people think of MBSE is only applying to systems engineers, I'll ask a group of, say, electrical engineers. My background is electrical engineering. I'll say, hey, do you electrical engineers, do you ever use block diagrams to diagram high-level views of your electrical, subsystems? And of course, they laugh and they say, well, of course we do. So it's like, well, that same kind of modeling, that same kind of symbolic modeling could be used within a discipline, of course, because electrical systems are systems too, right? And as you're implying, chips are systems too, right?
I'll jump in there too and agree with Todd that I think we're just dipping our toe into things. We're not really as far along as we'd like. What's practice versus what we envision are different at the moment. I think we envision something much more comprehensive as we define systems engineering, very broad, full life cycle. But we're not always applying it in the same kind of, with the same kind of breadth, and it's distributed and interconnected and team-based. And I think that's where the future is going. We just got to get it there.
So I guess I'd jump in. I agree with you, Troy, and tugging on the thread that Todd pulled on. I do think it's what's going to happen going forward is really moving from what I would call sort of domain system engineering that is disconnected from the value network and moving it to enterprise and connecting it. And I think that that's where, some of the things that we are challenged with, today, like model-based assurance starts to become an enterprise competency and allows us to accelerate the way that we respond to putting capabilities into the operational field.
So Mike here in the chat in the Q&A asks an interesting related question. He says, how is digital engineering different from traditional engineering and from MBSE? Is digital engineering the same as MBSE, or what do you guys think?
I think digital engineering has a implication of a full digital thread. And I think that's something that we have not had. We still do a lot of throwing stuff over the wall. And I think that's some of the work that Siemens and I are doing, in IBM, is how do we get this stuff to be seamless across disciplines and across what have been very separate tool sets.
So, so to what extent is that? And we just tease that a little bit because several of our panelists, including you, Brett, are from companies that are making tools, right? So is this a tool concern? Is this a problem we have because tools are too separate? And what kind of interconnection do we imagine needing in the future?
What's funny, I mean, it's a great question. So first of all, you can look at it in two different directions, certainly by the tools, but what we started with was the process, and we had to engage with double E's who are doing wiring diagrams and network design. And then how do we apply that with the system model? And then how do I apply that down to the software and deployment of that? So all elements of it needed to be tied together. And I think that's been a really good lesson learned from us, is work on the process, work on the personas, then figure out the tooling.
Yeah, and I'll pile on to that, because we talk about tools a lot, but I think it's the problem we need to solve and the things we need to do are so far beyond tools. It's people and process. It's holistic, right? It's the combination of all three. And if you lack any one of those three in transforming your company, you're probably not going to get there.
Yeah, I'll piggyback on that. It's a socio-technical problem, and we're so focused oftentimes in INCOSE in other domains and what the current focus is, such as competencies, then process, then models, and we deep dive it, and it is all of it all together, and the transformation is going to require all of it. And we often say it's the cultural or the organizational change that's the biggest inhibitor, but then we have to ask ourselves, well, is it inhibited by how we're working with the technology? Is the technology possibly part of that inhibitor? How do these things all kind of bind and work together?
Another dimension I'll add into that is, and you mentioned it when you mentioned the organizational part of that socio-technical culture there, Troy. Some of it's not just the competency of individuals in using the tools or using the languages and applying the skills or doing it cross-domain. It's the managers of that. If our managers comfortable in managing programs where they're used to being able to go in and edit or do things, and now they're asked to do it in a language maybe they don't understand. Does that slow some of the adoption of some of the work that we're doing, whether in MBSE or, as we just talked about, the greater digital engineering cross-domain disciplines, because they've lost some of that certain amount of management style and control? And is that another facet of culture change that we haven't prepared for?
I guess I'd come back. Sorry, Barclay, I looked like you were going to say something, but I guess I'd come back and, back in 2014, when we started to look at what the topology looked like from a competitive perspective and trying to make sure that the digital acquisition context would be fully enabled. And we talk about acquisition tradecraft, which has all those elements in it. We looked at how to connect up sort of world-class applications into the extended value network or the extended enterprise. And I think that, that is going to be a key building block of moving, into that future.
Yeah, well, that's perfect lead in here, because I want to go right at the heart of something here. So brace yourself. Okay. So, we've been doing MBSE methods, and there's been methods published in books and in various standards and so forth, right, for years. We've been doing models mostly in SysML, but some other things too, right? So we've been doing this for a long time as an industry. So what do you say to someone who says, look, we in our company, we have people trained in MBSE. We've been doing lots of models, let's say in SysML. Where should we be looking for the benefits? Is MBSE just some kind of secret sauce? Like if we just do a bunch of MBSE models, then good things will just start to happen somehow? Or what is it that makes it effective or not in a given situation?
And I would say, Barclay, if you think of MBSE as this silo, this thing, you're just going to do MBSE and life's going to get better, I think you're going to be disappointed. MBSE, it's in the connection with the other aspects of engineering and manufacturing and product support and the whole life cycle of your program. It's, like I said before, I think of it simply as the digital transformation of systems engineering. And I think of the 30 years of systems engineering I've done. I wasn't just thinking about systems engineering. It was, how did I guide and shepherd and work with the design engineers, with the manufacturing engineers, with all those things. So I think, back to answer your question, in a silo, MBSE won't help you that much. It can, there are benefits, but it's the connection to the whole life cycle of your program and your product development where you see the benefit of MBSE, that interconnection.
Life cycle is important because of the changing world of the products, the organization, the company that we're also talking about. My paper drawing for something that I get, my IKEA kit, for example, that I have paper instructions in there, and that's fine. I don't necessarily need a model for it because I expect to be able to build that product the same exact way every time. But when I'm in the middle of developing a complex aerospace system, things are still changing. And it's there that the power of the model and having the MBSE and connection to know all the other disciplines related to a certain change, that it becomes very powerful in trying to recognize all of the different changes that I make. We realize that actually in Lego kits now. We actually do have a paper instruction guide that comes with a Lego kit, but you can actually open your app and get an alternate series of Lego instructions for other things to build with a given kit. They've made a model, and they've made it useful to me as an end consumer that I don't need to just buy exactly the product I have. That's just an example of change, but that's what we're looking to all do with all of our systems too, right?
So just one
of
thing.
the items.
Oh, go ahead, Brett.
No, go ahead.
One of the items that
Or
Stephanie hit on here is that this is an iterative process. And I think we've got to realize that we've got to go back and forth between an MBSE model, keeping it current, keeping it under config, as well as linked to these other disciplines with some level of configuration between them. It's a challenge, but that is a lot of the work that I see, in aerospace and automotive, where, we're trying to help them do that. And it's been a lot of work, and we're not done, but that is a huge challenge for these industries today. And it includes functional safety, it includes cyber, it's all these different elements that they're using these MBSE models for, but they're not specifically called out in our discipline today.
Yeah, I think, what question are we trying to answer? When have we answered it and burned down the risk through enough analysis? We have enough confidence that we can say that this has helped us in where we are in the life cycle. We're trying to get shared understanding, right, and knowledge about our systems. And where there's risk, MBSE can really help reduce that risk. But if we model just to model, that's where we tend to get in trouble sometimes. We just start modeling, and it's interesting, right? But we got to really think about the context and when we're done and when we provided that value.
So Troy, this is perfect. This is great. I want to go a little bit deeper with this, right? So you're suggesting that, there's sort of two ways, as you said, right? We can just do MBSE models because, gee golly, we went to this fantastic panel that INCOSE put on, and they all said to do MBSE models. So I guess we should start doing MBSE models, and we'll go get a book from Sandy Friedenthal or whoever, wherever, right? And we just start doing this stuff, right? That's one way. But you're suggesting something different, that we actually think about what's the purpose of doing a model at all, and what are we trying to use it for? So how much does this happen? And is this going to change as we go forward in the future, the use of what we actually use these models for?
That your last point. We're very interested in building models right now, making a lot of models, building a lot of models. The real value comes in using models, right? Using them so used for a particular purpose, and they're fit for purpose. They have the level of confidence that we can put in them for the decision that we need to make with them at that point in the life cycle. So we really need to be keeping that in mind early and upfront. What's the purpose, and when has it met that purpose and that level of confidence to use?
Just to sort of expand on that, Troy, and getting back to a point that Brett made. When we go to release a model, so there's a release process, and one of the things that you do when you're doing the configuration verification review is not just waiting to identify what folks identified the need for that model view or that model diagram for, but then before it's released, actually validating that the model that was built satisfied that defined need. And so that's what you'd see in your configuration verification review. So you're not releasing things that are distracting and noise level into the ecosystem as you move it from narrow stakeholder group into broad stakeholder group consumption. Because a big thing that we don't want to do is poison the environment by having people not realize that there are bad models that may be constructed and there are good models, and we want to have a process that actually brings discipline to that practice.
So can I challenge the panel to maybe come up with a brief story or something? Many of you guys, of us, have worked with multiple companies, multiple clients, multiple situations. Can you give some examples of where a MBSE model was used successfully for something, just what you guys are talking about, right? Okay, you got to know what you're going to use it for. And then we're going to use it for this, a story of when it was used that way and how it was maybe seen as better versus some other way of doing it, right? Because if the model wasn't around, they probably did that activity somehow anyway. And how was the model better at that particular thing? Is that spark any stories? Go ahead, Todd.
I'll start, Barclay. I won't name the company. I don't want to give away any secrets. I'll talk at a high level here.
Yep.
But I was working, let's just say, an aerospace company a few years ago. And we were talking about some of the ways that we really invest a lot of time and money. And we were looking at the testing process. And we noticed that we spend a whole lot of time just writing a paper document of a test, then converting that to a test script, running a test script, getting results, putting the results together, creating a report. And this was for a commercial aircraft, a flight control system in an Ironbird. We're looking for certification. So I challenged the team. I said, could we use a model could we model the test process and the test, and could that model create the test script? And as the test script ran, could the test script document the results? So that basically we're doing all this through a model. And of course, we went to the customer, and the customer said, well, that's great, but I still want to see a paper document. So we actually had the model create the paper document too. And all the work was done through a model. And I kept saying, I think it kept us off the cover of Adweek on this particular project, because you go into a large test program thinking, we're going to run it once or twice. Well, we ran these tests 10, 12, 15 times before we were done. And the automation that came from the model and the ability for the model to do a lot of the mundane tasks that engineers used to do really saved us on that program and allowed us to deliver it on time and fly the aircraft on time. I like to say to engineers that kind of struggle with models, start by automating the mundane. And that's a lot of what we did with that model. We automated a lot of the mundane tasks that engineers didn't want to do. They did the interesting creative stuff working with the model, creating this, and created this whole test process in an automated fashion that we use to certify commercial aircraft.
So really interesting, right? Really clear benefit. Well, let me even challenge this before we go on to some other panelists may have other stories that I want to hear too, right? Is that story, so some people have been commenting in the questions in the Q&A, like, all right, how do we convince our executives or our managers or our higher ups, right, whoever that is, that MBSE, we need to do this, right? So is that story that Todd just gave, is that convincing? Or do we need more? Do we need some kind of, do we need to force Todd to put it into an ROI to 2 decimal points, or is that good enough? Like, is this what we need, or what? Todd, you can respond, or anybody to that.
I can say for my particular company that there was a real angst when we started down this process, because we've never done this before. This was a risk, and I was to some extent kind of betting my career as a leader in this company on this process. But I said, we've done this before, where the method was, well, let's just take a giant army of engineers to write all this and do all the scripting. I said, I don't want to do that anymore. Let's let the computers do that. And it became the model for how we did all future programs in this company. And while there was risk in the beginning, this ability, and I don't have a number to say how many millions of dollars we saved, but I'm quite certain we would not have delivered that control system on time had we not taken this approach. And that was enough to convince the executives at this company that it was the right thing to do. And what we did, and all future programs were based on this one's success.
So Todd, it sounds very familiar. Back in 1999, I did a presentation down in DC at Boeing, publicly available, with some folks from McDonnell Douglas doing work, model-based areas. So I was writing standards for that at the time. And one of the things that I think that, when I heard ROI, I think it's important that we think about what the avoidance is. When we look at model-based assurance, we're not there to have an ROI. We're there to avoid mistakes that get discovered way down in the life cycle that are hugely costly. And so that sort of avoidance of error, hugely costly in terms of resources, time, failures, etc. So, being able to avoid those on critical systems, and Todd was just talking about aviation systems, and these are critical systems that if we can avoid errors, if we can wring out errors early in the life cycle, we don't have, bad failures, satellites crash into planets, etc. So anyway, you get the idea.
I think there's another element to this that I've seen, especially in automotive, and the whole MBSE process has helped them think about what the functions are on their vehicles instead of thinking about the mechanical systems behind it. It's this ECU or it's this computer. Instead, doing a functional work breakdown structure, just having MBSE to be part of that and to think of the vehicle in a very different way and to start thinking of it more along the lines of what Tesla did to the industry many years ago, which is, introduce this over-the-air updates, continuous improvement. It's a very different way of thinking. And yeah, I think you'd appreciate this, Barclay. I mean, there have been reorgs in some of these industries where they actually called it Project Conway. I mean, they're going, yeah, we're architecting things wrong. So you know what I mean by that. And so that has been a big change. I think the other one that I'm seeing right now is leveraging it downstream to the software side, because they're seeing orders of magnitude, and I mean orders of magnitude of increase in productivity in writing code by utilizing the SysML model down to the software level, converting it to UML, and going ahead and writing autocode out of it. That's been a big change in the industry as well.
I'll comment real quickly from an INCOSE perspective in the transformation role I've been in at different times earlier, some years ago, and even with MBSE. And working with a cab and hearing what director level type folks are saying about MBSE and what the questions are, I really felt that over time I saw this shift from people asking about why would I do MBSE and what's the ROI, this why and ROI, in a shift to kind of, I got to do this now and how do I do it? Now and how, right? It's as if someone wants to say this digital transformation thing really isn't occurring, okay, that's a different question to answer, right? It is occurring. Now let's talk about what's most important to digitally transform. Maybe how we innovate, how we engineer. That's a pretty important thing to transform. The question is how. How do you do that with value? Because you can do that without adding value, and you can do that by adding value. And some of the examples given, I've been involved with things that are really about that allocation. Do we allocate it to how we automate some things we know how to do today? Or do we allocate it in model-based to how we innovate, how we come up with new concepts and look at new architectural options, how we can explore a trade space we can never see before because we can have a model that can help us see things that are an order of magnitude beyond what we can really do with our own kind of thinking or in a team. So I think it's how we apply it more so than whether or not we're going to do it or need to do it today.
And actually, I think that couples to how we consume it, right? A large part of what we utilize the model for is to get people to consume things that we're convinced they're not reading. If we were handing them something in a paper document, if we're handing them something in words, and that cross-domain barrier again, it's well, how much do they really consume and understand that? Even if it was a block diagram, if they weren't invested in it, if they didn't understand that, and this gets to a point where I've seen the adoption difference between a manager who is willing to consume what you tell them and a manager who doesn't want to consume because they are convinced they need to learn the SysML whatever that script was language and doesn't want to know the syntax and they feel they need to know that super syntax level. That's one of those differences in picking up that. And I think there's a big change that we're seeing in MBSE and in this application, even in the programs. I could give an example very similar to Todd's from a large aerospace company that three of us had worked at together before and on a DARPA type project. And that was one that was a great example where that manager from the DARPA customer wanted to see and dive into the model. The model became the delivery. We didn't have to deliver documents. We didn't have to deliver any products. And the ease that he followed and was able to use a clickable version of a static model was something that his team was totally impressed with because they got more information out of it. Our team on our side was more impressed with it because they understood that we weren't, bookkeepers or bank keepers in the system engineering area, just tracking requirements and what they told us we did or didn't meet and how we could get to critical design review. They understood the ones that were on their specific subsystem and became owners of it in that way. but it wasn't that we did everybody's a system engineer, everybody has to be in the tool, everybody has to know the language. It did make it much more consumable, though, data that they needed for their area. It's
a great theme there. And I sometimes talk about it this way, see if this fits with what you're saying, Stephanie. There's a certain amount of we've got to get real. And what I mean by we've got to get real is, as somebody just mentioned it, right? So they said, well, there's not really an ROI. There's avoiding a big failure, a big potential failure later. But that can fit into ROI, because what you'd have to think about is, let's get real about what's our likelihood of having some kind of a big failure later. And we have to get real about our history as a company, as an industry, all this. What kinds of things are likely to happen? What's the average number of big, huge problems we get per year, or whatever? You know what I mean? It's some kind of norm. And we say, look, with MBSE, we can reduce that. We can cut that in half. And what's the cost of those big failures? Well, it's X millions. All right. And if we reduce the likelihood to see, it all does come down to math somehow, right? But in order for that math to work, we have to be real about the normal experience. So in your example, Stephanie, what's the cost to the program of people not reading the documents? You know, what does that cause downstream? What does that waste later? What does it cost us in future business, et cetera, right? And we're avoiding that somehow.
But we don't capture it, so it always makes it difficult to say, right?
Right, and when we do capture it in documents, there's an immense number of documents. And how consistent are they one to the next? If we did read them all at once, right? It's highly unlikely we could really achieve that, right? So, you know, in consistency management, configuration management is one of the major areas of failures on programs and systems, right? And so how do we get that? And how can we maybe query versus read an immense amount, right? And so there's a lot of opportunity. Once again, how do we allocate our work to what we can consume? We read documents, and people need documents because anybody can read them. Sometimes we have our languages in our particular disciplines or domains that inhibit some of that communication. Really what we're trying to do is exchange knowledge, and documents are a good form of that, but models are a good form of that. And we're really improving, SysML v2 is improving. How do we interoperate? How do we exchange knowledge faster and better in a precise, consistent way?
So Troy, I think you bring up a good point, and you know, maybe it's too early to bring it up, but you know, when we're talking about architecture evolution, and we talk about reading documents and connecting architectures and models, in order for us to consistently connect things that go across the life cycle, as Stephanie had brought up, and go across acquisition in the overall value network, we have to understand what architecture evolution is. And if we documented it in documents, we actually don't have the connectivity to be able to help that architecture evolution have the longevity that they typically need to have, right? In the B-52, I think they say that the pilot of the last B-52 hasn't been born yet, right? So that architecture is an enduring architecture. So we have to take that into account and be able to have those enterprise systems. And as we're talking in the chat, and what, you know, Brett brought up, you know, on CM, that CM isn't, hey, I got to check in CM and a whip. It's the extended value network CM and how we enterprise connect those things. Thanks.
I'm still kind of looking forward to see any other stories. I mean, Todd gets the blue ribbon so far for the best story, maybe the only story so far. So
here's one.
You got one? All right, go ahead.
I'll put one out there. So this was a automotive OEM global company. And honestly, we learned a lot in this project with them. And it was really rolling out this functional decomposition and on a global basis with them on being able to do that in an effective manner in the automotive industry. So first of all, we'd already done adaption to it to support automotive SPICE from a best practice perspective. We leveraged everything from the cyber and functional safety standards that are out there. So those were already in there. The piece that we found we were missing was how to do that also with another standard, which is AUTOSAR, which we didn't think at first. AUTOSAR is a functional kind of thing. It's down at the software level, but it's absolutely part of the functional work that you have to do early in the design. And so being able to adopt it and change it and put in, you know, methodology and help them understand how the tools can support that was an awful lot of work. And I think it relates to us being able to better communicate to the domains that we're talking to. And by that, I mean both industries as well as engineering domains.
All right.
I can give the rest of the story. I started there.
Okay.
Where I said we were delivering a model because we did have a customer that was interested in it. Part of the reason he was interested in it is that we took an aggressive shortened time period between being brought back to life, if you will, with a contract, and had to do a critical design review staged in a less than 9-month period between when we should have had a preliminary design review for a major hypersonic system. That's a challenge. That is difficult. We're not just, it's not just that it's a complex system, we're also dealing with technologies that we don't yet understand, whether it's the material or the shape or the coatings and the heat resistance, et cetera. There's a lot that goes into that. But there were still all of the same operational constraints about something that would be tested, launched, part of an operational test at a launch site. The challenge here was how much did all of the different teams that were still already managing their specific technologies that they were trying to advance also understand the larger system. We finally were getting them to recognize the amount of holes in their behavior and the anticipated behavior of the vehicle, not looking at the actual flight or performance metrics. People really knew what our targets goals were for those metrics. But when you're looking at the actual operational behavior, what happens as we go, that was a breakdown that nobody had ever done on that program. And that was something that was made possible by having that model tied to the different requirements and allocated to our different domains so they understood exactly which of their parameters were influencing that. We found a significant number of holes. We found a different way of saving money like we just talked about because we stopped creating any sort of paper deliverables. Everything was done electronically. That saved us an immense amount of time. And it was one of the first times where we actually pushed forward and did a model-based review for one of our subset of critical design reviews. I can't tell you how much I was shaking that day because it was about doing math live, right? Did I test the computer? Do I have the bandwidth? Is my tool going to go down? Everything went through my mind. Do we have the backup slides just in case? Yeah, we did. But of course, those were just images from the model dropped onto them. But I had a backup system that way. But doing that live, the customer had, and even our other partner teams on our own team within our own office had more confidence in what we were doing because they could pick the thread that we would pull on. And even though we had some written out ones that we were doing in terms of here's what we wanted to show you, how we stepped through this, why we found this was an error and what we've done to fix, they were able to pick stories for us to do live. And
this is really good.
It changed the understanding. It changed.
And I think this is, I'm sorry, go ahead and finish your sentence there. Okay. But I think this underscores a really important point. You really have to do some looking and some thinking about what are the benefits of the model. And some of that may be the same creative thinking that loops back to what Troy was saying is you've got to have the purpose in mind. So what is it we're trying to accomplish this model, and looking at what we got out of it in the past may give us some clues. I'll throw in one story of my own just to complete this little story section here, and then we'll move on. Is another program I was working with, and they were doing MBSE, and I was asking them, all right, what did you get out of doing MBSE models, right? And they said, well, what we think the biggest benefit was it helped us win more business from this program, follow-on program business. And my little ROI antennae perked up there, and I said, well, let's see if we can put a number on this. So you normally get some follow-on programs from a program like this, right? And they said, yeah, sure. I said, okay, of the opportunities you get, about what's your normal percentage of winning those? And they said, oh, we normally win about 80% of those, let's say. These aren't even the real numbers, right? I said, okay, now, given that you had this MBSE model, you feel like that helped you win more? He says, yeah, we feel like it would help us win more. Well, how much more? Well, we feel like we could win 90% of them instead of 80% of them. And I said, well, that's only a small difference, right? But then I said, well, wait a minute, how much are these programs worth to the company? And they gave me some numbers and stuff like this. And it turned out that 10% increase, or it's more than 10%, that increase from 80 to 90% of a win rate was huge in terms of value to the company out of doing the models. So it was kind of an unexpected place to look. When we did the calculations, it made a huge difference. Todd, did you have something on this?
That's okay.
No, okay, you just made a noise. All right. So good with the stories. Now let me move on to something a little bit different here. So I love to quote Clemenceau, right, who said, "War is too important to be left to the generals." So what the question I want to ask for the panel is MBSE too important to be left to so-called modelers? In other words, people who they may not have a lot of knowledge or a lot of experience, but they know how to do models. So we just leave the MBSE to them. Is MBSE too important to be left just to modelers?
Yes.
Okay. Yeah, I know my mistake of making it a yes or no, but please elaborate.
I second that.
The question in the chat was there as well, and
yeah.
My response, or what I wanted to respond, I don't even know if I did, I might have blacked out, but was that these are the tools of the trade for the system engineer today. And so if you happen to be good at modeling, you're filling out one of the legs of the stool for the system engineer, right? But they also have to have, typically when you're talking about big examples, so think about B-52, basically 5 system engineers, and they worked to come up with, lead system engineers. They worked to come up with that aircraft over the weekend after being turned down by the Air Force general. And so, when you think about this, these are the tools to rapidly connect the things and refactor them in order to get them to the point of success. And we often talk about training, but we have to think about workforce of the future, education. And so system engineering is not SysML, it's not a tool, it's not necessarily being a modeler, it's actually being a system engineer and then using the tools in the education to be able to deliver on the architecture that you need to describe and the architecture rationale. And one of the things that Stephanie said earlier was about the a weapon system or something like that. One of the big challenges we have today is the digital modernization of the value network of the acquisition system. This is a massive system engineering problem that includes that trade craft that we need in there. So just FYI.
Sorry.
Yeah.
Thoughts on this? Go ahead.
Yeah. Another thing I'll add to that is that having modeled and building different kinds of models, you learn an immense amount about a system, whatever it is you're really focused on, because you iterate and you think about it in different ways. But right now, I think that the modelers, those that are really deep into this, are gaining a lot of knowledge, but that knowledge isn't propagating out to a broader community very easily. And that's what we really need to have this, that one, people recognize the value, 2, have that shared understanding and consistency. There's just immense value in getting that across a team or an organization or an enterprise. And so the quicker we can do that, the better off we'll be, rather than these pockets, right? And that's what we have at the moment. And we're working hard to bridge them, but we just need to do more to kind of bridge those pockets of knowledge that's getting deeper and deeper.
It's part of the evolution too. I rarely, at least, do, and this isn't my field, so I don't look at it, but you rarely are hiring drafters. You're hiring engineers who have a background in mechanical design. It's kind of the same purpose I see there too. Somebody who's managing those also knew how to do it. That's the evolution that we're seeing. So I don't necessarily just want a modeler. I want somebody who's also going to grow to manage and understand what is the system's thinking, what is it that goes into the problems that we're using that particular language to solve. I think even in software, we're not necessarily just hiring people who code in a single language, and most of the time you need to know multiple languages. Well, most aerospace engineers, automotive engineers, oil and gas industry, I'm trying to think of other industries there, you still know something about fluids, even if the structural analysis is your strength and something like that. I think modeling fits in that same way here. There's something else we're bringing to the system. That's just one way of conveying it. And so if you are just a modeler, what are you actually doing as a participant in the rest of that entire design and that life cycle?
You used a really good analogy there that I'll pick up on. To me, it's sort of like the difference perhaps between an architect and a draftsman or draftsperson, right? Where both are doing drawings, both are drawing the building, right? but one has a very different background, a very different perspective. They're actually bringing the design of the building, the architect. The draftsperson presumably is drawing what someone else has come up with somehow, right? So is there a difference between somebody who's just drawing a model, in SysML or whatever, right? And someone who's actually doing the systems engineering using the model, right? It's the tool for doing it, and they're using it because it's the most effective tool they have to do their systems engineering.
Seems like there's been a progression in others, even within CAD, where sometimes that person is the same person very early on in the evolution of things. And as it gains traction, then you start learning more, having more people who learn the tool and the language and can start using it to express. And they might be working with other engineers who are guiding that work. And I think we're seeing some of that happen even now. And I think we'll see it continue to evolve, but it, as it grows out to more people. I think there's just part of a natural evolution there.
Well, I want to protect INCOSE from getting sued here. So I want to deliver on the promise of this session, which is that we were going to talk about the future of MBSE. So let's put our crystal ball hats on here, if that doesn't mix metaphors too much, and look out 5 to 10 years and say, all right, what do we think systems engineering and MBSE, assuming we even use that term still in 5 years, right? But what do we see that looking like in 5 to 10 years? How will the picture be different? Like, let me give you just one example in the tool space, right? Right now we have some very separate tools, as people have mentioned, like here's this modeling tool for that, here's this tool for that, here's this requirements tool for this, and this SysML tool for that, that kind of thing. Will it still look like that in 5 to 10 years? Or will tools sort of merge somehow into more unified grand tools or not, right? I mean, you got to notice that Microsoft Word and PowerPoint are still 2 separate tools. Do they need to be tools? Could they be done in one tool? I don't know. Maybe tools stay separate for good reason. So what do y'all think? 5 to 10 years in the future?
So I'll give you my hope at a couple levels, Barclay. So first off, we talk about MBSE and SysML and these kind of things, and not to completely, but to a large extent, I think we're still in the mode of sophisticated models to convey information in better ways than documentation. And there's lots of value in that. That's a good thing. I hope that MBSE progresses to the point where the models really do significant things for us, be it analysis, help us make decisions, help us write code. And I'll give you an example of a problem I hope that MBSE can help us solve. If you look at the aerospace industry right now, studies I've seen, the aerospace industry is about 30,000 engineers short right now. Where there's need 30,000 more engineers than we have. The predictions, which is about 10% of the need. The projections I've seen by 2030, it'll be 70,000+ engineers and 20% of the need. It's unsustainable, Barclay. The need for, and which means we're not going to have sustainable aircraft that we need to design. We're not going to advance commercial space. We're not going to be able to design the systems we need to protect ourselves, because we're not going to have enough engineers. I hope that MBSE can provide the level of modeling and automating the mundane, doing things significantly with the model, so that we're not 70,000 engineers short by 2030, and we're not looking to, we're not damaging the industry, be it automotive or aerospace. That's my hope of where MBSE can go and what MBSE can do in the next decade or so.
I'll throw one. I'd say there's 2 things I'd like to see come out of this, and certainly areas I would want to see us continue to grow on is the industry specificity. All right, if we want aerospace to use this well, we got to make it real for commercial aircraft. We have to make it real for defense systems as a larger system of systems. I think we've done some of that, but we're not nearly specific enough for med device and for others to be able to do that. The second piece is looking at it down to some of the domains and trying to understand the applicability. And I think with SysML v2, we make it a lot more customizable. We make it a lot more adaptable. That's a good start, but I think we still got to take a look at it and make it more out of the box for specific industries. And I'll go back to semiconductor as being an example. How do you do that for a semiconductor company? How do you do that for, somebody who's mainly doing printed circuit boards? That's a different discipline. I think we need to be more specific to that.
I think there's some natural tensions in what we need to do and where we need to go. Our work is very distributed, right? Huge supply chains, but yet we want to be more interconnected, and that can be a challenge. We want to be more team-based, but we're also getting more detailed in models and very deep in semiconductor business, for example, or in materials. Our models get deeper and deeper in domain knowledge, and those silos are actually really important to build that expertise and to keep going deeper with research and everything else. But at the same time, we want to connect. And so I think there's a natural challenge to become more distributed, but more interconnected, more team-based and collaborative. And I think too, that we need to be thinking about this augmentation versus automation, right? How do we keep the human in the loop of sorts, right? It's not just automating things, it's about how we work with and how we allocate, as Todd said earlier, to machines or to people. And then how do we check that and validate that and, you know, collaborate? And that's where I see things going in the future.
I see things potentially fractionating a little bit more and becoming more contentious before they become less contentious, depending on the SysML v2 adaption strategy. The reason I say that is there are things that I'm super excited about for it in terms of the specificity of the language, but that also takes understanding the language to a different abstraction beyond the diagram views. And so for those who have been adopting or gaining adoption in using SysML's language or the tools as a replacement for Visio or PowerPoint, I think many of them will be sorely disappointed or not progress. And what that means is that some of our basis for transformation will have changed and shift, and we might see some conflict in those areas. But at the same time, I also see that the people who have been learning this either in school or early career development in 5 to 10 years are going to be the thought leaders then. So maybe they are already more adapting of SysML v2, or maybe they are already in a mindset where they're used to learning more languages. They were in college where they were already having to know Python and other languages just to do their schoolwork versus, you know, very singular code areas. And they were learning SysML or other languages at the same time as well. So if they're managing now, maybe there are other ways that they are bringing that in the same way as maybe they are investigating using a company-trained GPT-3 for how to help some of their people utilize each one of those. I hope that's less than 5 years away, actually, in certain ways, but the 5 to 10 years away, I'm hoping that we're learning on how to utilize these differently and better. Maybe that's making a way of our cross-domain links that we're trying to build, that understanding across the different disciplines is hopefully easier, but I don't think it's going to come with pain.
No, for sure. And, you know, there's a related topic in there that a number of people have mentioned it in the Q&A and so forth, and that is this role of standards. And so let me ask, you know, all of us about this, right? Are we suffering for lack of standards? Is it good that we don't have certain standards? We have a standard language that most people have aligned on called SysML, but that's simply a standard for a language, right? It doesn't tell you how to do MBSE or what models you should do or anything like that. Is it fine that that's all freewheeling, or do we need more standards that tell us more how to do this kind of stuff?
So
I'd argue some of those standards are there today. We're just not adopting them from the industries, and the industries have been the ones driving them. I think there are very, you know, representative ones that we could be leveraging more.
So just on the standards thread, and then I would like to get a chance to respond back at the earlier question. You know, I think that Brett's right, there are standards, but typically when we look at the standards, we have to take the industry standards and then create institutional standards that allow us to apply the specifics that are peculiar to each institution that allow them to be able to do things the way that they do them in compliance with or conformity with the standards, depending on which standards that you're complying with. Some standards have principles, other standards have shalls, other standards absolutely avoid shalls. And so I think that having those institutional standards, institutional meaning the enterprise or value network, is very important. And then to go back to the earlier question, you know, when you're looking at what that future looks like, I recently produced a modular open systems white paper, and embedded in that is that assurance element, right? And so earlier Todd was talking about how do we solve that problem? And so one of the things on looking at the problem that you're solving in modular open systems, which is a superordinate characteristic versus a subordinate one, you have to solve the modular open system characteristics while you're solving the survivability characteristic, while you're solving the safety characteristic of the overall system across the life cycle. So you're also doing maintainability. And so applying machine learning to these aspects, be they reinforcement or unsupervised or supervised, is a way that we're going to start to tackle these the scale of these problems. And then when we start to figure out how to tackle those to make better decisions with fewer labor hours, then we can possibly start to scale to try and tackle some of the labor challenges that Todd was addressing there. So I kind of answered two questions simultaneously.
No, that's no problem at all. And I hope people are reading the chat, because some of our participants here are offering some quite interesting answers to some of these questions as well. So it's more than just the panel. You get the benefit of what the other attendees think too. Well, I have one more question, and then I want to go to a round of quick concluding comments by each of the panelists. Okay, so be ready for that, right? But the question is AI. So what is or is going to be the impact of AI on systems engineering and MBSE? Can you give any examples of that, or what do you see, hopes, dreams, aspirations for AI? What do you think?
I'll comment on AI. Artificial intelligence, I once again kind of shift the emphasis to augmented. How do we have it help us, and how do we know what to allocate to machines and what to allocate to engineers? And how do we look at that interplay, right? I think chess has been an example and an analogy different times, and how, you know, Kasparov lost to AI, right? And then we started looking at teaming, and he found that in teaming, some of the masters would lose to novices when they teamed well with AI. So it's about, how do we augment? How do we bring process? How do we bring the people, their knowledge, their skills, the augmentation, as the automation? How do we bring that all together? So I think it's looking at it holistically that's going to make the biggest change and difference. And it's something that we just will have to do, right? The systems are so complex that we need that assistance.
And I'll chime in that I think exactly how Troy said, it's identifying where can we apply it with confidence and trust first as we bring that into our systems that we're designing, and is it used in the system we design, the system we use to design the system, or designing the system we use to design the system, as I know Barclay likes to point out, 3 levels that we have there.
All right, let's go for a round of concluding comments here. I wish we could continue on. We could probably do this for several hours, right? And I guess this is just the first Calling All Systems, right, Honor? So we're voting to have more. So let's have more. But brief concluding comment. We'll start with Garrett.
Wow.
If you have something, you can pass.
Well, yeah, so I am extremely enthusiastic about some of the things that folks have talked about today, and very much appreciate being on the panel with you folks, highly respected. And I am extremely pleased to see the direction that, you know, all of the industry is going in, increasing the level of discipline, understanding that we are trying to solve very real enterprise problems, very real system engineering problems, very real ecosystem problems, and bringing the application, you know, of something like SysML in, you know, 2006, and then, you know, seeing the advent of a convergence on UAF in 2017, and we use UAF every day. And looking at the ecosystem and developing architecture evolution. Roadmaps is what other people might think of them as, but those are architecture evolution views, and stretching those out to, you know, 10 and 20 years is, you know, what's necessary when we're looking at major transformation of large ecosystems. So I very much appreciate the time on the phone.
Very good. Thanks, Garrett. And next we go to Brett.
I'm sure I'll hit on the AI thing just a little bit, because we've done a lot of work on helping people pick algorithms. What is the right algorithm for this? There's no AI expert who knows all these algorithms and is an expert in all of them. They have to specialize in certain areas. So being able to help people pick them, I think that's part of what you need to think through. And I think some of the MBSE thought process of how we go about doing the engineering could be leveraged on thinking about what is the role of AI in the system and how you start to think through where you're going to apply it and where it makes sense. I'd like to see that taken on a little bit.
Terrific. By the way, we're at the top of the hour. We'll go to the other concluding comments, but just so you know, the recordings of this will be on our website, incose.org/callingallsystems. So you can watch that for recordings, for news. We'll also send a follow-up note to you. Stephanie, concluding comment, please.
I'm excited for what the future of system engineering, especially MBSE, does have. I think that something to consider as we're looking at the monumental uphill battle we still face with some of the adoption, with some of the transformation, is to address exactly who you're trying to either convince or needs to transform, and then also still to be willing to transform yourselves. I think continuous learning in the environment we're working with applies at all levels of practice and management, and trying to ensure that we're working all of those different levels of learning and adoption is going to be key.
Excellent. Well said. Continuous learning. And finally, Todd, representing our session sponsor, concluding comment.
Hey, thank you, Barclay. I want to say thank you to you. Thank you to Honor and INCOSE for sponsoring this. And thank you to 400 people for stopping for an hour of their day to listen to this. It's been exciting. It's been a privilege to be a part of this. Thank you to all the panelists. I guess conclude comment, I am really bullish. I'm really excited to be a part of this industry. You know, I think all of us, I'm looking around the panel here and I see lots of gray hair on the panel. And I think to me, the exciting thing is we've been a part of creating something that's going to outlive all of us. A really key thing. I think, and I talked about just dipping our toe in the water, and I feel like that's what we've done with respect to model-based systems engineering and digital transformation. And there's so much opportunity. I think we've really created a foundation to be built on for the next 2 or 3 or 4 decades to solve, you know, there's so many problems we talk about, from staffing to climate change, to these things. And I really believe that what we've been a part of creating, not just the panelists, but all the people in our industry who called in today, we're part of something greater than any one of us. And to me, that's exciting. It's exciting to talk about this and to hear the future of MBSE. I think there's a bright future and can really make a difference in our industry and in society as a whole. And that's where I see the future of MBSE. So thank you to you, Barclay, and thank you to INCOSE.
Well said, and we'll wrap it up right there. So on behalf of INCOSE and the Calling All Systems program and our sponsors and our panelists, thank you for being here. So I'm Barclay Brown for INCOSE, and we'll see you at the next Calling All Systems. Thanks for coming. Have a great day.